ಆಯ್ತು ಪವರ್ ಬಂತು ಅದಕ್ಕೆ.
ಮೇಡಮ್ ನೀವು ಕೇಳಿ ಸೌಂಡ್ ಬರ್ತಾ ಇದೆ. ಹಲೋ, ಸೌಂಡ್ ಬರ್ತಾ ಇಲ್ಲ.
ಆಯ್ತು ಪವರ್ ಬಂತು
ಮೇಡಮ್ ನೀವು ಕೇಳಿ ಸೌಂಡ್ ಬರ್ತಾ ಇದೆ. ಹಲೋ. ಹಲೋ ಮೇಡಮ್ ಬರ್ತಾ ಇದೆಯಾ? ಹಲೋ ಹಲೋ, ಓಕೆ ಫೈನ್.
Share the screen, sir. Let us know.
ಅದು ಓಪನ್ ಮಾಡ್ತಾ ಕ್ಲಿಕ್ ಮಾಡೋದು ಕ್ಲಿಕ್ ಮಾಡೋದು
Okay. Sir, can you share the screen, sir?
Share the
Hello.
screen.
Hello, sir.
ಅದು ಓಪನ್ ಮಾಡ್ತಾ ಕ್ಲಿಕ್ ಮಾಡೋದು
ಹೇಳಿ. Hear you.
Sir, can you share the screen, sir?
Share the screen.
Hello, sir.
ಅದು ಓಪನ್ ಮಾಡ್ತಾ ಕ್ಲಿಕ್ ಮಾಡೋದು
ಹೇಳಿ. Hear you.
Sir, can you share the screen, sir?
ಅದನ್ನ close ಮಾಡ್ತೀನಿ.
Hello, sir.
ಅದನ್ನ close ಮಾಡ್ತೀನಿ.
Hear you.
Close off.
Share the screen.
ಸ್ಟಾಪ್ ಶೇರಿಂಗ್
Share the screen. How share screen, sir? ಇಲ್ಲ accept ಮಾಡ್ತೀನಿ. ಅವ್ರು ready ಇದ್ದಾರೆ.
ನಾನು ಬಂದೀನಿ
Sir, please share the screen.
ಅವ್ರು ready share ಮಾಡಿ.
ನಾನು ಬಂದೀನಿ
ಕಾಣಿಸ್ತಾ ಇದೆ.
Yes, sir. ಹೌದು ಕಾಣುತ್ತೆ ಸರ್. Is not.
ಇವ್ರದ್ದು
ಮೇಡಮ್ ಇಂಟ್ರೊಡಕ್ಷನ್
ಸೊ ಈಗ ವಿಡಿಯೋ ಆನ್ ಇರಲ್ಲ ಅದು ಸ್ಟಾಪ್ ಮಾಡೋದು ಅದು ವಿಡಿಯೋ.
ಸ್ಟಾಪ್ ಶೇರಿಂಗ್
Mahesh. So I'll start. ಇರ್ಲಿ. Let both of them be. ಇಲ್ಲ ಬೇಡ.
ಸ್ಟಾಪ್ ಮಾಡಿ
I'll start. ಇರ್ಲಿ. Let both of them be. ಇಲ್ಲ
ಬಟ್ ಡಿಲೇ ಆಗ್ತಾ ಇದೆ, ವಾಯ್ಸ್ ಎಲ್ಲ ನಿಧಾನಕ್ಕೆ ಡೆಲಿವರ್ ಆಗ್ತದೆ.
Good afternoon to one and all. I am Sunita, professor in the Department of Computer Science and Engineering, SIT Tumkur, coordinating this session today. A warm welcome to all the participants, faculty, staff, students, research scholars, and industry persons to the second session of webinar series IT Industry Trends on AI in Software Engineering. I cordially invite Mr. Mahesha B.R. Pandit, founder and CEO, Rhytify Technologies, as speaker to this session. We all are aware that AI is transforming all business functions, and software development is no exception. We now have models that can deduce from data what features and patterns are important without a programmer explicitly encoding this knowledge. Yes, AI in software engineering is a wonderful domain to understand and explore. Before we start this session, let me introduce today's speaker, Mr. Mahesha B.R. Pandit. Mr. Mahesha B.R. Pandit is founder and CEO of Rhytify Technologies, which focuses on developing AI and NLP-based platforms and products. Mr. Mahesha B.R. is a global thought leader, MIT Sloan alumnus, mentor for startups, senior executive, and a hands-on techie who can create energy and drive transformation within an enterprise. I'm proud to mention that Mr. Mahesha is a distinguished alumnus of our department who secured 4th rank in his UG program under Bangalore University. He did his master's program from BITS Pilani. He pursued an executive program in general management from MIT Sloan. He is currently pursuing his PhD from Chitkara University, Punjab, and 2 micromasters, namely AI and bioinformatics from edX. Mr. Mahesha's 22 years of global software industry experience spans across multiple domains, including manufacturing, automotive, aerospace, financial services, media and entertainment, education, government IT, and pharmacovigilance. He has served multiple global marquee customers, including Bosch, Infosys, Airbus, Capgemini, UK and India, Value Labs, Aris Global, Salesforce, Unilever, Johnson & Johnson, and many more. He was a consultant to UK government's Technology Strategy Board and has helped UK businesses to adopt cloud computing. He's also an advisor to few engineering colleges. His focus areas include artificial intelligence, model-driven software engineering, rapid application development, software defects reduction, and digital governance. His keen interest is in disruptive innovation, NLP, software modernization, designing, and building effective software. He is recognized as a most valuable player by Infosys, cloud expert by UK government's TSP, and global expert on cloud technologies by Capgemini. Mahesha is passionate about writing, oil painting, travel, and teaching. Yes, this afternoon we have a very knowledgeable industry expert with us. Now, I request Mr. Mahesha to take over and start the session on AI in software engineering. Over to you, Mr. Mahesh.
Thank you, ma'am. Thank you for this opportunity to share what little I know on AI. That's a long introduction. Yeah, thank you for this opportunity to share what little I know. Just when I put up the first slide, you must have noticed that I think there is a small voice delay in the software, in the platform. So let's just. Are you able to see my screen?
Yes, we are able to see the screen. There is no problem.
Okay. So just share my screen. Are you able to see the PowerPoint slide? The first slide. Okay, just a minute. This PowerPoint, there is a little bit of problem. I'll convert it to PDF and I'll show you. Okay, so like Sunita ma'am mentioned, I did my studies at SIT, and those were the best days of my student life. Maximum homework I have done is at SIT. So our school used to run like ashram. It used to start at 7:30 in the morning, 7:30 to 9:30, then 10 to 12, and then 2 to 5, and sometimes some special labs used to run between 5:30 and 8:30. So I've not seen this kind of dedication anywhere else in any other academic institution. So I'm proud to be alumni of SIT and have warm memories of SIT, and I wish the very best for the college and faculty of SIT. Yeah, so little bit about my company, Rhytify. We are guided by MIT Sloan School of Entrepreneurship, Martin Trust Center. And we have recently been recognized as the collaborative research partner by Bharat Electronics in cloud computing. So at last, until now, we used to say we are good people. Now, at least there is one public sector unit which has recognized our niche skills in cloud. Today, okay, there's a brief look at our development center. We have a nice facility here in Bangalore, close to metro. And these are some of the people who work with us, my staff. We are a small team. We are driven by integrity, innovation, and detail orientation. So we try to do we look at details of everything and try to we have a healthy disrespect for what is normal. So we try to do things as much as possible in a different way. So we have done a lot of focus areas we have, and we have done a few things in these things. Computational biology, bioinformatics, cloud, interaction between humans and robots, e-governance. We have some of these focus areas we're trying to understand and provide new solutions in these areas. We have a tie-up with Subaya Research Center. That's they own the Max Hospital in Shivamogga. So we are together solving some problems related to medical artificial intelligence. E-governance is one area where we are trying to add some value. We have recently created a solution to govern research within Indian academic setup. So we keep doing things. And coming to today's topic, I'm passionate about AI as well as software engineering. I would like to develop software that is defect free, free from all the defects. So in this area, we built a solution called review as a service. Once the customer uploads a review item, whether it could be an architecture or code or anything, so our bot does a pre-review. And then a human reviewer provides his comment. So we are trying to experiment here in this space how much AI we can use to review technical artifacts. So this is one small piece. We have began our journey in AI and software engineering. You must have seen this first slide. I don't know how many of you saw this first slide. So I've written a code here. So once I wake up while we are alive, we need to do this. We have to ignore this AI noise. There is so much noise about AI. It is really frustrating. Everybody wants AI, ML, as if you cannot separate those two words. The moment you utter the word AI, the next thing you have to say is ML. They go together, right? AI, ML, whether it's a small time intern or a small time researcher or an expert, industry expert or a marketing, everyone talks about AI. So in my opinion, there's a lot of noise about AI and misplaced understandings and high expectations and disregard for data. There are so many issues I see, but I'm also excited about what AI can do. So in my opinion, AI, I'm happy with I'm comfortable with the definition that it is augmented intelligence. That is what it is at its current stage. It can help us. So it is not going to replace any of the normal functions that we do. We are far from that. But yes, it will replace many of the routine things that we do, like status inquiry from a bank or those kind of things. Like you can automate and you can predict what the customer can do on your platform and those kind of things. But it always augments our current intelligence. So what our focus area here is to bend our heads down and just keep innovating and publishing. So that's the model we subscribe to. So this is how the session I have planned today. So I'll explain some myths about AI and software engineering. Then we will look at some use cases. And then we will take a little bit deeper look at how you can predict software defects using AI. And then I'll take the question and answers at the end. So I request for you to hold your horses until we go through the first 3 sessions, because your question could be answered in my next slide itself. So I'm going to take about an hour or hour and 10 minutes. I'll try to wrap it up by 10 minutes past 4 so that we can have some 20 minutes for the question and answers. So let's begin with the myths. There are some statements, people keep saying these kind of things. If you are in marketing, you will know this. Black is the new blue color. Perception is reality. You have to lose in order to win. So these are all, very tricky things. You will never know whether something is a myth or a reality. So that's my belief. So with that introduction, I would like to ask you, if possible, if there is a polling feature on this platform, we can take a quick poll. We can take one by one. So first myth is AI can do little in software engineering. This one, many people have told me that there are no use cases in AI in software engineering, for AI in software engineering. And some of my academic friends, they were asking, hey, do you have any problem statements for my PhD students in AI and software engineering? The subject is so dry and all. So is there a polling feature, ma'am, on this platform?
No, sir, it's only
Okay.
chat.
Yeah. So most of the people do believe that the first point, AI can do little in software engineering, is a current belief amongst many people, definitely practitioners. At least academicians are slightly optimistic, but they are also believing that there are not many topics to apply AI. So it is largely a myth. Reality is you can do a lot of things with AI. I'll show you in the next section what they are. And then there is a general belief that AI can write software by itself. So this is what many people say, hey, be afraid of AI. It can generate software by itself and then it can take over the world and all. Fortunately, right now it is a myth, but it could be true in the next 50 years or so. Software modules can be classified as defective. Somebody told me that software defects are a natural part of software. There is no software that is not defective. So why do you want to predict why do you need AI to predict? Whereas common sense itself says that if you develop 100 modules, there is 100% chance that at least 90% of them contain at least one defect. So this is the sorry state of software engineering. It is true also. Defects, it's the nature of this software. It's a highly cognitive work product. So software does have defects, although there are many ways to reduce those defects. But the question here is, using AI, can you classify a software module as defective or non-defective? This is not a myth. You can do that. You can classify modules as defective or not defective. The next question is, can you estimate the number of defects per module? For example, there is a security module. Can you guess how many defects? Guess is the wrong word. Or can you estimate how many defects are going to be there in the software security part? Similarly, login module, authentication module, how many defects? This is also not a myth. You can actually, there are techniques to count and estimate the number of defects that are likely to be there in your end product. Module by module, you can estimate the defect count. The last one is interesting. We have enough defects data for AI to work on. AI needs data, right? Without data, AI, you have to rely on deep learning. But you may not have enough insights to build deep learning solutions. So you definitely need defects data. But who is sharing defects data? None of these industries, we don't share. We don't share, we are lucky if we are storing those defects data. We use tools, techniques, sometimes we outsource testing. We get only summary results like, okay, there were 14 defects, we have fixed all 14 of them. Such messages we get. But we don't get defect data. And even if we get it, we keep it within the company. We don't release it outside. So then how do we do research on AI and software engineering? So the fifth one is a kind of a myth, but it is slowly becoming reality. There are good people out there who are sharing defect data. For example, NASA, Eclipse. These projects, they are freely releasing the defect data on which researchers like me rely to run our prediction algorithms. So this is the current state. So with this, let's see what AI can do in software engineering. See, there are some people who say AI can help in software engineering in many ways. When we don't know who said it, the general practice is to assign it to Mark Twain. the unfortunate fellow who did say many things in English. So feel free to associate the quotation to Mark Twain if you don't know who said it. Okay, so here are some boring use cases and some interesting use cases. So these are the use cases as per a famous American company. I don't want to take names here. So I'm, just kidding, classified them as boring and interesting. I just wanted to keep this webinar a bit light. So there are some poor jokes, so just excuse me. So the use cases from the management perspective, AI helps planning the staff that you have on the actual software development work. It is more or less technical, but it's, I can quote one example here. I was working for an American airline industry. They were an airline carrying millions of passengers across America and the world. They had a very complex IT system, which had ticketing, reservation, flight scheduling, cargo, even allowing passengers into the aircraft, scanning the boarding pass. There were many functions were being done. There were 16 modules. So they had 16 teams, one for each module. And every Tuesday, they used to integrate their code, and all hell used to break loose on on Tuesdays when everyone brings their code and integrates together. Confusion. There were a lot of many things failed. That's what happens when you merge code in software. There will be side effects. So such complex cases, the AI can predict things and they can allocate work across teams and ensure that the chaos is minimized. So though it is management stuff, there is enough room to deploy AI there. Next one is transforming old technology to new technology. This is one passionate area for me because we started it very long. I think in 99 we started transforming COBOL code to Java and all. 99, 2000, that's when the Java had made its first entry. In fact, my company name Rhytify is derived from this transformation of legacy systems. I have some IP in converting old code to new code. So I was looking for a name for that, and transforming old to new, the medical procedure is called as rhytidectomy. So that is plastic surgery. People undergo plastic surgery in order to look young. So that's why I kept the name Rhytify for that product. And when I started my company, I used the same name. But unfortunately, not many big investments are coming in legacy transformation. Hopefully with AI, we are able to unlock some money in this area. We do pitch in a lot of legacy transformation proposals, but it is not gaining much of traction. Okay, third one is identification of duplicate code. This is very important because most of the developers, they just import things, copy code from Google, then they check in and there are hundreds of branches on Git. So this is a nightmare. So across software, your complex software, if you can identify duplicate code and avoid few repeated merges and all, you can save a lot of complexity. The other thing is, which no one cares much about, is benchmarking. How good is my code against, say, that of Amazon? Now there is a very good security system in Amazon e-commerce platform. So how is my e-commerce platform compared to the other top 3 e-commerce platforms of the world? But not many people care about this, but this is a very interesting and valuable application. Only when you benchmark your software against the best in the industry, only then your journey towards the betterment begins. The fifth one is really boring, and I definitely, I don't know whether it is true or false. Using AI for predicting expenses and costs. This might look like a joke, but if you are a large company like Infosys or Google, these could be very significant because you should be able to predict the expenses and costs of your employees and also your hardware, especially in the cloud context. Just today, we got an inquiry. Someone asked, "Hey, I want a Netflix alternative to Netflix. I want to exactly build a software that exactly looks like Netflix. It has to have all the features of Netflix, but I don't know how many users will be using it." So in this case, how do I give the proposal? I can give it for building this software, but what will be the run cost? Month on month, how much is the cost incurred by the customer? I don't know. So we need models here to predict the expenses and costs. But when you apply that to employee expenses and travel expenses and those kind of things, yes, the problem looks like a joke, but believe me, it is not. None of these are they appear different, but they do add value, and there are paying customers for these use cases. Now let's look at something more technical. Most of us are techies, I assume. So we are more interested in source code complexity, predicting faults or defects, estimating the quality of the software. Not only this, we want to understand how the software can fail. Where is the risk in my code? uh, Recently we are building an e-commerce platform and a lift elevator maintenance system. Both of them use credit card data. So I'm nervous now. I want to know where and how this can fail, because there are hackers out there waiting to crack into our credit card data. And though people say credit card validation, payment gateway integration is only few lines of code and all, but the key thing is, where do I keep the credit card validation data called PCI data? Your platform, is it PCI data compliant? If so, how? If so, what kind of controls we have? On one hand, I need to know that, and on the other hand, I need to know how bad is my code, where is going to, how is it going to fail, under what circumstance, and what risk I'm carrying. So these are some of the current use cases. Of course, there are so many others, like you can predict effectiveness of testing, coverage of source code coverage from your testing. You can predict vulnerabilities based on the behavior and expertise level of your staff. You can extend each of these use cases and create a lot more. Let's look at one area which is right now I'm doing my research on this, and we are also building a solution for this, is predicting defects. Software defects are killing people. We don't know about it, and definitely we're wasting a lot of money. This is what I'm putting up. I don't know how big number is this. Yeah, it's 213 lakh crore. It is 10 times the COVID package announced by our current government. Yeah. So this is the loss that we are incurring per year. This much of money we are losing every year due to software defects. That is $2.84 trillion. If there are any NRIs who want to see the world in through the dollars, yeah, 2.84. Can you believe it? It's true. And software defects are causing more damage. Software is everywhere. There are 36 billion devices that run software. Half of the world is online. There are billions of lines of code. Okay, the software, people have lost a lot of money. NASA lost its Mars orbiter. We lost our moon landing in Chandrayaan. Ariane 5 rocket exploded. Just a minute, I'll close the window here, there's some noise. Yeah, I'm back. Ariane 5 rocket explosion was due to a software defect. NASA Mars orbiter was lost because the software did not calculate the distance properly. There was unit of measure mistake. I'm talking about meters and feet. So one module was calculating distance in meters, the other one in feet. These are legends. I don't know whether they are true or not, but definitely it was due to a measurement mistake. Okay. Ariane 5 caused huge losses, 8 billion. And in Russia, Ukraine side, there was a huge explosion of gas pipe. That is the largest known non-nuclear explosion that was caused by a software defect. So the world spends about $4 trillion, but out of that, 2.84 trillion is lost. It goes into fixing the software defects. Okay, so 17% of your spend going into this is quite a huge number, no? This one. So that is enough motivation for us to use any available technology to minimize defects. So this field is called as SDP, software defect prediction. Some people also call it as DEP, defect prediction. So the objective is to identify software module that may contain at least one defect. So that is classifying modules as defective and non-defective. And also estimate the number of defects. So people have visualized an ideal SDP model and they have described it like this. It should be able to classify defects on the basis of severity. So it's not enough if you tell me that the authentication module has defects. It should tell me authenticate module is likely to have 13 defects, out of which 5 are going to be major, 7 are going to be minor, and 1 is going to be an observation kind of thing. So it should be able to give me that severity. And also security related defects, because the world of hacking is becoming more and more sophisticated. Okay, so we need to isolate and identify security related defects as early as possible in the life cycle. And not only defects, also the vulnerabilities, where the code is likely open for attack and abuse. And I have to do all these things on a system on which nobody has trained the system. For example, I have to be able to predict defects in my program using the defect prediction data of NASA. So that is the expectation here, cross-project defect prediction. See, I don't have time to train my model on defect prediction. First of all, I don't have data. Second is, I don't know how to build all these models. I can't build a model for every project. I'm a commercial software company. So the expectation here is, give me a model which is already pre-trained. It could be trained on NASA's Mars orbiter or ISRO's moon lander software. So that I have to take and predict defects in my e-commerce project. Okay. So that is the expectation. Cross project, the defect prediction should happen across companies, across projects, and across different releases of the project. So if there is a defect prediction model which delivers all these things, that is our ideal. That is our goal. At least the goal should be high enough like this so that we can work towards it. Initially, it looks very difficult to achieve. Yes, everything is difficult at first. But this is the gold standard for defect prediction using AI. So where does it fit in, STP, in the whole lot of things? We know only about some standard things. So the right-hand side is the software engineering bubble. The left-hand side is the artificial intelligence bubble. So we are talking about software engineering and AI coming together So we have machine learning as a subfield of AI, and verification validation as a subfield of software engineering. In that, we are looking at evolutionary learning of AI, and which focuses on prediction and testing of the software engineering side. So that is where the innovation is taking place. This is where the two points actually meet: evolutionary learning and prediction and testing. So this is where the spark of innovation is going to come on predicting defects. So CPDP is cross-project defect prediction. That is using a defect predictor that is prepared by someone else on some other software. I will use that to predict defects in my software. CPJIT is cross-project just-in-time defect prediction. I don't have time for building the model and all. I want the release is coming up. I have to give up the software for testing. So just in time, just predict now. I don't care. Or maybe if you are developing something on Eclipse, Eclipse itself catches so many syntactical issues, right? Similarly, when you run your code, Eclipse kind of IDE should be able to say, hello, your code, this module is likely to have 13 defects. That is just in time defect prediction. When the development is happening, the defect prediction is also happening. Oh, this config.python. Okay, expect 7 defects from this. Okay, and believe me, 3 of them are going to be major. If something like that pops up in our window, we'll be able to immediately correct the issue then and there. That is the interesting field of cross-project, just-in-time defect prediction. See, this looks like a magic, but believe me when I say that it's all due to a process. There is a process for SDP. First, you have to look at data, defect data, and pre-process it. That is, remove unwanted data, label things correctly. Then, out of that, you select features. Here, the defect data consists of information like length of the code, how many functions are there, how many classes, how many methods, how many nested calls within the class methods, how many variables, yeah, what is the developer's productivity, developer's experience, the language, so many things we will have. Those are the features of the data. So out of that features, how many features you need to predict the defect? That is a classical research problem. Do I need, see, one of the debate which we normally do is, hey, this project, this was a Java project. Will it work on Node.js? So is language a feature that we should worry about? The answer is no. You can still predict the defects across languages. Language is not a major parameter here, according to the current research. You'll be surprised, no? It beats the common sense, isn't it? We think that Node.js and all this Angular, these are difficult modules. They're likely to have more defects because it is new, people don't know and all. But the number of defects predicted on these technologies compared to traditional Java and .NET kind of thing are similar. There's no difference. So language, you can afford to ignore the language part of it from your feature. Here feature means metrics. What we usually call as a metrics, here we are calling it as feature. So you need to reduce the number of features. You pick up only those things which are going to help you predict the software defects. Okay. You would be surprised to know that length of code is still a major feature which will help you correctly predict the number of defects. We were of the, see, when we are writing programs in languages like COBOL and all those old technologies, the length of code was an important feature. But not anymore, because we have this object-oriented concepts and this dot concept, right? Class dot method dot invoke. That's it. 2 lines of code does a lot of things. So, but still, the line of code is a very good indicator of number of defects. Okay, So like this, you reduce the number of features, you take only the handful of features that will help you predict things. And with that, you build a model and train it and check its performance. So that is how the defect prediction goes through. Okay, here is a colorful one. Should have shown this one first. The heart of the thing is the model and the training that happens in an iteration. This is a typical AI programming model. So you feed in the training data and then parameters, and you run it multiple times. So your learning is captured, and this big cylinder at the top gives you the necessary input data. And once you have that, you run your model on a testing data and get prediction results. Here we are getting three major outputs: defective module list, count, module wise count, and then vulnerable sections of the code. And once you have those, you evaluate your model, how good it actually performed, so that you can take appropriate business decisions. So this is the generic model we're trying to improve over. The current research is happening with this model, and we are focusing on all these areas. For example, there is a lot of focus on defect data. So people are looking at available data models and checking how good they are. So I have slides for that. So let me continue. So before I get into some more detail, I just want to understand, well, are there any questions at this time? I know I said I will take questions at the end, but if there are anything that is not obvious right now, or which is making understanding a little bit difficult, we can take a couple of questions at this time and then move on. Are there any questions?
We have questions, Mr. Mahesh, but we can take it at the end of this session.
Sure. Okay, fine. Okay, so let me continue. So defect prediction happens at many levels. So I started with this blue box. I wanted to show box within a box, within a box, within a box, but I did not have time, so I just showed one box. So excuse me for that. First thing is general software defect prediction, which is just one time, just for curiosity, or you have a software, you just want to know whether it is defective or not. So one is a first one. Ignore the first one; it is a very loose definition. So you can do defect prediction across releases, sorry, within a release. So let's say you are producing version 1, release 1 of your software. Okay, so you will be doing many attempts to get it right, isn't it? So you'll be hosting and checking. So every attempt, across every attempt, you can predict the defect. Okay, first time I'm hosting it, I'm pushing through Git. Okay, Git push Heroku master. Okay, now I'm looking at it. Okay, there are 14 defects. Now let me improve the code, and let me once again do Git push Heroku master. This time how many? It reduced to 9. So you can do it within the release. So that is called as intra-release defect prediction. Then we have inter-release. Hey, we have released version 1 of this software. Now I'm working on version 2. So how many defects I'm going to have in version 2 based on my performance in version 1. So if you train the model on version 1 of your software and then use it to predict defects in your version 2, then we are doing inter-release defect prediction. Similarly, cross project. I am training my model on the defect data of some other project. It could be Mars orbiter or ISRO's Chandrayaan or ICICI's bank data, e-commerce or Amazon's e-commerce app defect data. I don't care. I'm taking that from the market, or maybe it could be my own company's another project. I'm trying to train. I'll train my AI model on that project, but I use I'm using it to predict defects in some other project. That is cross project defect prediction, CPDP. This is happening within the company only. Okay, so this is a very hot area for research. And then within company defect prediction across departments. So still I'm a large company. So the projects done by model and to predict fine, it is still within the company. So CPDP and WCDP, that these two are somewhat similar. I will use their data, train my model, and I'll predict. So this is idealistic scenario. Not many companies share. Forget defect data. We don't, we don't collaborate at all. We are always suspicious of each other, and that is why you don't see much reuse within the industry. When we were growing up in the system, we thought that reuse is going to be a big thing. We thought, these are all done by other people. Why I should reinvent the wheel? No, most of us still write the login component. Why? How many times I have to write the login component? Yeah, but still we do, right? Many things. Error handlers we write. So many things we write. We could easily share them across, but we are not open enough. We cite many obstacles. Most of the obstacles we quote are wrong. We are just pretending. That's it. There's no spirit of collaboration across companies. If it happens, at least if we share the defect data, it will be awesome. Then we can build intelligent XDPs. Okay, complicated slide, but there is nothing much to it. It only, see, understanding any new system requires you to focus on the language part of it, the taxonomy. You learn the taxonomy, you'll get a grip on the subject. So this is just an introduction of various terminologies which I've already explained, a bit more graphical and a flow. Flow is nice in this one. So software fault prediction. See, we were using the term software defect prediction, but here is the taxonomy SFP. Then we have intra-release prediction, cross-project, again, similar things, yeah. So this only highlights some of the terminologies used. So let me skip this right now. So I said, how do you do defect prediction? You have to look at the metrics. These are called as features. So software metrics, there are different types, the product related and process related. Then there are traditional ones, and then there are object oriented metrics, and there are new ones. So like this. So in the traditional ones, most of you might be familiar with some of the things like source line of code, slog, function point. Yeah, that is very computer sciencey thing. Not many people know. So cyclomatic complexity is classic indicator of defect. Not many people compute. So if you have these metrics, it will be really useful for predicting things. This is just an introduction to the various kinds. See, not only on the product, you can collect on the process side also. How many times you have changed? How many changes occurred in your module? And how many lines of code were deleted? How many files are there in your system? Okay, and see, personal commit sequence. There's always one developer who is so nervous. Every time one change he makes, he commits and then pushes it to Heroku, and then there he sees the result, right? So I'm one of those kind of guys. So the number of times people commit, yeah. So revisions, number of revisions. So many things like that. They come from the process side of things. So the other top three boxes come from the product side of things. So all these are useful. Not only that, we need some meta information. That is information about the project. For example, under what context are you doing it? Is it a public project? How many functions and how many classes are there? Yeah. How old is this software? Is this the 40th revision or the first revision? So that's the maturity of maturity of things. Here, another important point is at what level we have these defect data. Is it at the project level, or is it at the package level, or class level, or method level? The number of lines of code. Okay, if the question is how many lines of code are there, if you answer 3 million, then your answer is at the project level. So you are giving me the LOC, lines of code information, at the overall highest possible level. But that cannot help me to estimate defect at method level, because I don't know how many lines of code are there in a particular method. If I ask you the same question, how many lines of code are there? And if you answer it like this, I have overall 3 million lines of code. By the way, I have 30,000 modules. So then I can divide one by the other and think that, okay, fine, these people have about 100 lines of code per method. So it helps. The more information you give, the more the granularity, better is the defect prediction. Also, you should look at the data quality issues. There will be a lot of outliers, missing values, redundant, irrelevant data, all these issues. It reduces its own set of problems, some of which are shown on the screen. For example, class imbalance. Okay, fine, I'm doing cross project defect prediction. I obtained Mars rover project defect data, but it is very clean code. So the only 10% of the code is defective. But I am working with very amateur developers. It is possible that 50% of my code is likely to be defective. So there is a class imbalance, right? The mixture of ratio of clean, defective versus clean is 1:9. So I'm training the model with that kind of imbalance, and I'm trying to try it on a project where the defect to non-defect ratio is 1:1 nearly. So that introduces its own set of problems. And higher dimensionality. That means this Mars rover data has value for 100 metrics. I have value for only 4. What do? There's a mismatch. So the quality of prediction goes down. So you need to look at your data set as well. Okay. Yeah. So now when we are talking about data, let's talk about a little bit about it. There are only 5 public data sets across 86 products. Okay, and these are the data sets. Do you recognize any Indian company in this? No. Because we are a software services superpower. We are not software product superpower. Right? We don't. Have you heard of any Indian software product used across the world? Not really, right? Then why do we call ourselves as software superpowers? We should think about that. So these are the people, these are the data sets available out there. So they are also not clean. Only one thing is clean. Okay. Only one out of these is clean. I don't want to tell which one it is. Okay. So you need to do a lot of pre-processing of data. You need to normalize, standardize, clean up. Then again, solve that class imbalance problem. Then that heterogeneity problem. This Mars rover data could be for 5 projects of mixed up size, mixed up technologies, and mixed up contexts. So this is heterogeneous data. It's not clean. It's difficult. You have to sort that out. And not all of them are properly labeled. Modules are not labeled, so you have to cross check the modules whether the defective module was labeled as defective or not. That you have to check. A lot of cleanup required in the data set. Similarly, on the metric side, lots of metrics. Standard ones are about 20 code related and complexity related metrics. C and K is this package. Sorry, C and K. This gives you these about 6 metrics related to the product, object oriented. So LOCD, still it helps the number of lines of code defective. That's the one which helps counting the number of defects. Okay. You can minimize metrics. You have to minimize metrics, otherwise your model becomes complicated. And then you can rank these metrics also. For example, should we consider lines of code ahead of number of methods, or do you want number of methods to be given higher priority while modeling? So that is feature ranking. So you have to experiment with feature ranking and all, and then you can see the model performance varying. To build the model, there are a lot of varieties of techniques, about 31 of them. So many classifiers we have. First, these are the techniques used to classify models as defective and non-defective. See how many techniques. Okay. And then how do you evaluate the performance of the model? There are many F measure and G measure. These are some of the techniques used to check how perfect is your model. Not only that, there are so many others here. Recall, precision, area under the curve, G measure, F measure, accuracy, and all. So then you have to validate your model, right? So for that we use many validation techniques. The holdout family is, we use 50% of the data to train the model, and remaining 50% to test the model. Then you have cross validation. Here also you do it 10 times, 10 into 10 fold. That is, you create 10 folds, 10 parts of your data, use 1/10 of it to train and the remaining to test, something like that. So there are many methods for validation as well. So how are these models doing right now? So that's a very good question, isn't it? So after talking so much about software defect prediction and all, how are we doing? Some of the models are giving very good performance. There's a definition for what is high performance here. The recall should be 0.75, precision and accuracy, all three. That means 75% of the classification should be accurate and precise. And recall, there are different definitions for this. Recall is the number of things that you have correctly identified out of all the things that you have identified. Okay, but this high performance is met in only 4% of the projects that we are tested. So still the accuracy is about, okay, the model that I am trying, it is about 79% accurate, still not there. So we have to do a lot of things. And the performance is even worse when it comes to cross-project defect prediction. So we are successful in only 3.4% of the cases. You might be wondering what kind of speaker he is. He came and to talk about AI and software engineering. We thought super duper things are happening, and he's showing all these low performance things. See, I'm trying to tell you that this is a new field. Still things are going on. We have to do a lot of work. So my objective of today was to introduce that how difficult things are with AI. We all talk about things and we copy code from Google and then we put up a show, but real research is painful. And this is the state of the art. And it's also a tremendous opportunity. If any of you want to do PhD, this is one area where you have plenty of problems. In fact, I have listed about 19 gaps in this area. And I did only little bit of research, that too part-time research. So my external examiner in PhD said the general belief is that we don't have problem statements in software engineering, but here is a candidate who is putting up 19 gaps. So he was surprised to know. So if any of you are interested in advancing this field, this is a very rich area. So it is possible to predict defects and count, and to a reasonable degree of accuracy. 79% or 80% accuracy is not bad. Yeah, it is not good compared to 99.9. We understand. But we are at least better than humans, right? Better than your team lead. Okay. So to me, it is a more positive situation because there is a lot of opportunity to do things. Yeah. And some of the just-in-time part, the case I spoke about, I'm trying to predict defects right in that time of development. That is possible, but the performance is not great. What is Rhytify's dream in this, and Mahesha's dream? What is that we are trying to do here? So we are trying to visualize the future and trying to build that. My vision, or the Rhytify's vision, is to have something like a service like DPAS, that is defect prediction as a service. So I imagine a cloud-based service where things are hosted on a public cloud. So that cloud has a set of pre-trained defect models, and then shared data sets which consists of a lot of defect data, and also model improvement application. So different software development teams connect to this service and they get defect prediction in real time as a service. So how are they going to use it? So I have some slides I'm not able to show. I don't know why. Maybe the platform got bored. It is straight away going to thank you slide. Interesting. So let me open it from my paper. Actually, it's from, I presented a paper. Okay, where is it? Publications. Yes. So this full paper submission. Yeah, cloud-based framework for cross-project software defect prediction. This paper is still under publication from past 1 year. That is one thing I don't like about academics. You guys take a lot of time. Why can't this be reviewed and published? It's been 1 year since I wrote this paper and it's still under review. Okay, so I could not show this slide on that platform, so I'm trying to show it here. So this is how people use this cloud-based defect prediction system. So they log in, register into this front-end application. It has a front-end application here. All these are the users, so they log into this. They select the model. They select the model, because depending on the nature of the current project for which they are they want to predict the defects, they choose the model and then they upload the code and they select the level at which they want the defects predicted. Is it at the overall project level, or at the class level, or the module level, or the method level? And then they run the defect prediction model and they get the details of the predicted defect. Now this defect data is saved and go back into improving the model. See here, we will predict the defect and put it into this data set so that we can improve this model once again. One of the pain areas was lack of availability of data, right? So here we can collect the defect prediction data in real time as and when users use it. So that's it. This is how they use it. And there is another program called as Model Improvement Application. Its job is to look at the latest defect prediction experience and improve the model, the defect prediction model. So as you can see, this is what is our dream. We want to develop and to put this defect prediction as a service as a cloud application. Okay, so we are working on that. So this paper is a first step, and in the back end we have. If anyone wants to do internship with us, this is one of the nice problems that we can give you. I think there is something wrong here. I can't show this slide. So if you have any interest in this topic and if you want to help us realize this dream of developing defect prediction as a service, or if you want to do any research in this area, and if you have any thoughts, I'll be very happy to interact with you and discuss this subject. Now it comes up. Okay, so this is how they use it. And so, yeah, this is what I wanted to talk about today. I just wanted to tell you how things are in the area of software engineering and how AI can be used. I know I could have detailed out a lot of use cases, but I wanted to give a general description of the possible use cases and then elaborate one use case. So that was my objective today. So I hope I've given you a glimpse of how AI can help software engineering, and I've given you an idea about how much of work is out there. That is what this slide is showing on the left hand side. Yeah, building this innovative bulb takes a lot of effort, and it has to be done in a collaborative way. Gone are the days wherein an innovator sits in one isolated area, looks at the sky, dreams, and then comes out with a fantastic new idea. They are very rare. So collaborative research is the way forward. So join hands with us. Let us create a new world of new possibilities in software engineering. So that was my speech. Thank you very much for your patient listening. Time now is 5 minutes past 4. We have some time for questions.
Let us have the questions. The first question is, can AI be used to stop the spread of coronavirus?
See, there is a quotation which is a bit slightly controversial. So let me quote that. Artificial intelligence cannot defeat natural stupidity. Right? So COVID is a classic battle between AI and natural stupidity. If people don't wash hands, if the people ignore all the government says don't crowd. People say, who are you to tell us? We will, 100 of us want to attend this wedding. Yeah, because these two people want to get married and we want to enjoy the food. So they go there without mask and, so natural stupidity has more power here. What can AI, okay, jokes apart, what can AI do for COVID? Yeah, there are a lot of things AI can do. For example, it can predict the likely number of cases across BBMP wards. In fact, many proposals have gone like that using AI data. Yeah, and I think AI was already used to estimate the number of people one person can infect. someone said that it is 495 or so. That means one person has the ability to infect 495 people. I'm not sure what that figure is, but I believe AI was used to some extent. So you can predict. Definitely AI can help to see how the disease spreads. You can identify vulnerable areas and vulnerable types of people. I believe it can help. The only thing is we need a lot of information sharing. The data should be freely shared. Without data sharing, it is not possible.
Okay, let us take the next question. How does artificial intelligence impact our lives?
Like I believe that it is augmented intelligence. It's going to help us to do our jobs better. See, my job is to develop software. So if this AI can tell me where my software is going to be weak or produce more defect, it helps me, right? Similarly, if it can predict, one of our interns showed a demo of her project in which they had predicted pneumonia from X-rays. Well, it need not replace the doctor, but at least if it can tell the doctor, hey, look, this patient is likely to have pneumonia. I can see it from his X-ray. So then it helps the doctor, right? So AI is used first of all to remove all the repeated boring roles like your loan status, loan processing, loan application processing. These things can be done by bots, and there are bots that give you primary care. If you are not well, it will come. There are bots that can lift a patient from the bed and then uh, put them down. They know where to hold the patient. They're used in Australia, I think. So they are health care giving bots driven by AI. They can help. Similarly, AI can help drive complex equipment and vehicles that can prevent accidents. So many positive ways in which AI can change our lives.
Okay, the next question. What is the impact if defect predictions go wrong?
Defect predictions, yes, they are. The accuracy is still about 80 to 90% in best cases. That too, only in isolated conditions they are very accurate. So they will go wrong. The main objective of defect prediction is to test things better. If you have a limited set of people for doing testing, you can use the defect prediction data to allocate your testing resources. If there are 100 modules in your project, I need to know which one I should spend more effort on. So defect testing can help in those kind of scenarios. So when it goes wrong, you are likely to waste some resources. Okay, so defect prediction is not defect removal. So somebody asked me, hey, if you can predict the defect, why don't you remove it? Right. So as of now, if defect prediction goes wrong, you will waste some testing effort. But if you believe defect prediction results and fix only those defects and don't test the rest of it, then you will be causing more side effects.
Okay, let us take the next question. Will the impact be more than that of normal defects? The same.
It's unlikely, I think. See, normal defects, it is possible that you may not even notice the normal defects. So if the defect prediction identifies, then you'll be extra careful in looking into the module, right? So let's say there is an authentication module and the defect prediction says, look, based on my inputs, there should be at least 4 defects in it. So then the tester will be keen to identify so many number of defects. That may not be the case in normal, compared to the normal testing. Like that's where it helps your testing. That's why it is augmented intelligence, right? So I think a scenario with defect prediction will be better than the normal, wherein you don't have any indication at all. When the product goes to testing, the testers will have zero knowledge about the defects. They assume that every module, every line is defective and they have to write test cases. But with defect prediction, you can do your job better. If the tester knows that there are 13 critical modules that are likely to be more defective, and module 7 is likely to have 25 defects, they can be better prepared. So the scenario, your testing scenario is much, much better with defect prediction in place.
The next question, how AI is used in social media monitoring?
Social media monitoring is one of the earliest use cases for AI, when lots and lots of people were tweeting about their thoughts, about their products, and all this. This thing called a sentiment analysis came up. So the beauty was that the Twitter message has a limited size, 140 characters. Now it has increased, but there only still it is a small number, and each word you can look at it as a keyword, and then you can identify the sentiment behind that keyword. So when people did not like a service or a product, what kind of tweets they were putting up and what kind of words they were using, and compared to the words that people were using when they were happy. So with this sentiment analysis, the field picked up, and now they can predict all sorts of things. And even in recent elections, people are able to predict whether the candidate is going to win or lose based on the type of comments people are putting up on social media. So here the general, I think the question is asking about the how part. Okay, the how part is you should be able to read the social media tweets and messages. That is your input. And the technique used is break it up into keywords, and then classify the keywords as good or bad, or sad or happy or whatever emotion that you want to attach, and then you compare the combination of keywords, whether it is moving towards a favorable decision or an unfavorable decision. So probably you'll use k-means cluster or some algorithm to determine what is this tweet is all about. Is it a happy tweet or a sad tweet? You can classify from that. Monitoring, yeah, someone is angry, they are posting something against someone. Again, you can do keyword analysis. Here, most of it is natural language processing. So that's the technique that I'm aware of. So there are many more possible answers. For example, if you are Amazon, based on the review comments, you can identify whether the product is good or bad. And from the combine that with a star rating, you can do things. And if you want to understand why people are returning their product and merchandise, then you have to do a little bit of detailed NLP to understand top 10 reasons why people return your products. So there are many, many ways to use AI in social media. Next.
Next question is, which language is best for AI?
Your mother tongue, because AI is your thought process, right? You have to solve the problem in English or your language first, and then you implement it. But yes, there is no right or wrong answer for this, but I find Python to be much more useful, because Python has a lot of powerful libraries, and the ability of Python to crunch numbers and to do statistics is awesome. So I'm a fan of Python, so my natural answer is Python. But there is no such thing as a best language. It's all, what is good for the thing at hand. I'll give you one example, most recent from our own company. We started off with the mean stack, that is MongoDB, Express, Angular, and Node.js to solve to build a self software for elevator maintenance company. Then we understood, hey, wait a minute, they were asking for automatic scheduling, which is best done in Python. So then we switched over the web part also to Python. So this is a best fit for the solution on hand. It does not mean that this was the wrong choice of language. It is just now for this problem, this is the right language. So for AI, cannot be a best language, but yeah, Python might help in many situations. Similarly, there we have Go as well. That's also another one. So there's no best one, but it's a battle of it varies from context to context. But if you want to start with Python. That's my suggestion. Next one. Is that it? 7 questions? Okay, there are so many things on the live comments. Difficult to identify a question from this. Can we make TikTok video through AI? Am I audible? Okay, sure, okay. Am I audible? Can someone post a comment on the chat? I understand that SIT dropped off. So if there are other audience, I can maybe answer questions. I see some questions here. Okay, so if I'm audible, let me answer some of these questions. What about MATLAB? Yeah, why not? See, it's again a matter of your your requirement on hand. If it has all the right kind of libraries, you can go for it. Usually, we have to build some systems around your AI systems. For example, the web application, which delivers the result of your AI system. So then you need a friendlier technology. So maybe you can try a mix of technologies. Write your core powerful piece of the AI using Python or MATLAB or something, and then make it as a module. And you call that module from other friendlier systems like Angular. Angular is very good with the front end, right? So you call your library from that. So MATLAB is also nice. I don't know why people look for the best language. I think they're looking from the employment perspective. Maybe they want to change their jobs or find new opportunities. That is why people want to know which is the best one, where to focus the energy on. It is not definitely not a wrong question, but there are no right answers. That is a problem. Okay, how AI handles missed data in dataset and how accuracy is measured? Good question. So here, let me share my screen. Um, so here I'm trying to show my, yeah, this is my PhD work. So here, see, accuracy. There's a formula for this. Total positive plus total negative divided by all your observations. See, you can classify your observations as true positive and true negative, and false positive and false negative. See, when you measure something, it is possible that you got the truth correctly and you ignored the truth as well. For example, someone comes um, coughing to you, you're a doctor. If you identify that, look, you identify and tell the patient, like, look, you have some throat problem because you are coughing. So that is the case of true positive. Let's say the patient has come and is not coughing, and you tell that person, patient, that look, you have some throat problem because you are coughing. That is false positive, because you gave a positive identification that the patient has cough, but that is not the case. So that is false positive. That means you have diagnosed the case as the patient has cough, but in reality he doesn't. Then the two scenarios are opposite. False positive, false negative. The patient is coughing. You are telling him that there are no throat problems. That is a dangerous situation, isn't it? That is false. That is false positive. Similarly, you have false negative. Okay. The patient is not coughing. His throat is absolutely fine. He is singing actually, but you are telling him that, hey, you have a throat problem. So he can classify all your findings like this. So accuracy is measured as a ratio of how many times you correctly classified the truth, your declaration of truth, whether the result is positive or not. Okay, your declaration of the truth. So it is TP plus TN divided by sum of all your observations. So that is how accuracy is defined. How AI handles the missed data set. AI cannot handle the missed data set. You have to pre-process and write boring traditional code to fix that thing. For example, if your data set has missing column values, you have to call the FILLNA, FILLNA, data frame.filna, to and then fill those missing things with not applicable value, or you have to put a default value of 0 or false or something like that. AI, that is not AI. It is boring common programming. Yeah. Okay. Is there any other technology which will do jobs, tasks better than AI? See, AI is not a technology. If you think about it, it's not just one thing. AI has so many fields have contributed to AI. So let me just pull up that. How many fields contribute to AI? So many knowledge areas are there in AI. Okay. So it is not at all. See, just let me share a screen. So don't look at it as a technology. Okay. It is not a technology where you can pay a coaching center some money and buy that or use that. See here, it's a multi-brick foundation. Okay, AI, there is philosophy. Okay, see, laws of rationality and formal reasoning. What Aristotle said in 384 BC, that is helping our AI today. Okay, dualism, materialism, empiricism, principle of induction. Yeah, all these philosophy is helping AI. Similarly, maths is obviously helping AI. Algorithm, the concept of algorithm, Boolean logic, theory of NP completeness, probability theory, statistical bias rule. Bias rule came up in 1702 to 1761. That is helping today in mathematics. Then we have economics, the decision theory. Is it defective or non-defective? How do you take that decision? Operations research, yeah, that's from economics. Similarly, neurosciences, we build artificial neural networks. So we simulate a nerve cell. So that is coming from neuroscience. Similarly, psychology, human vision and all that, perception, we have perceptron and all that, right? Knowledge agent. So this is the contribution of psychology. Similarly, control theory and cybernetics, linguistics, computer science, of course, yeah. All these have contributed to AI. So don't look at it as just one better technology. Of course, if you want to use AI for, say, doing a payment to your bank, then what is the fun in that? It's a wrong fitment, right? It's all application. Yeah? There are things suited for certain things and things not suited for certain things. Okay, eighth question came up. How can AI help in detecting defects in totally new projects with new requirements? Yeah, this is a classical case of cross-project defect prediction. Here, totally new requirement means what? The defect is a defect. You are going to construct an answer for your new requirement using the same way in which you build software. So how do you satisfy a new requirement? By breaking it down into input, process, output, right? You will implement that new requirement, totally new or whatever it is, using traditional methods of input, processing the input in order to generate the output. So there is nothing new in this computer science, isn't it? See, all processes can be broken down into read, write, and update, isn't it? Create. That's why we have only 4 verbs in HTTP, right? Get, post, patch, yeah, and which is the fourth one? Release, delete, is it? Yeah. So everything boils down to input, process, output. So it's the same constructs you use. It's the same keywords, right? If you're doing it in Python, you're going to use the same if, for loop, while loops, conditions, and all that. Okay. So the goal is if you have data of similar project or even dissimilar projects will help defect prediction. Okay, what are the different types of probabilistic models useful in software defect prediction? So there are so many techniques. About 31 different techniques are used to in defect prediction. Yeah, so I'll just bring that up. There are so many classifiers. Some of the classifiers use probabilistic reasoning. So if you see here in this, yeah, there are so many you can think of here. Some of them are straight away logistic used, and then this partial decision tree. There are so many, most of them use probabilistic reasoning. So these are popular 31 tests. See, you also use Bayesian network, which is highly probabilistic. in nature. And genetic programming, still it uses a little bit of probability there as well. Yeah. Um, Associative rules, you can apply probability to determine which rule to apply and how to associate. There are some pure statistical methods like this logistic regression, the average counting, average voting. These are probably more statistic and less probabilistic in nature. What type of models you suggest suitable in AI for real data set of huge size? Not able to understand this question. What type of model you suggest suitable in AI for real data set of huge size? The AI data sets are supposed to be real, because if you use unreal data set, then you will be in trouble. Okay, so real data set I have answered. Huge size. I don't know what is a huge size, what makes up a huge size. But the expectation from AI side is the data set has to be huge. The higher data you have, the more data you have, the more better it is. There is no one single model that deals with your huge data size. You have to describe. See, what is a model? It's a representation of reality, isn't it? So if you get a huge data set, you have to describe it using a handful of features, right? That's what they choose the features which represent the model, okay? And you work with only those features. In fact, the opposite is encouraged. What is encouraged is, let me share my screen once again. What did we say? In the SDP process, we said reduce the dimensions, right? We said it. You have to choose only a limited number of features to build your model. So just because the data set is huge, you should not choose too many features in it, okay? See, feature reduction, you should use less number of features. The actual number of rows in your data set doesn't matter. What matters is how many features you are using to model or represent that huge data set. So if there are 100 million rows in it, but only 2 columns, then it is not a huge data set, in my opinion. It is huge in rows, not in numbers. If there are 1,000 features and 1 million rows, then you're in trouble. You have to choose only 5 or 10 which will help you. That's where you need to reduce the feature. Yeah, reduce the number of features. So huge data set, choose your future features carefully and ignore the number of rows. The program is going to handle the number of rows. You have to minimize the number of columns of the features that you select. Select only those features that matter. Okay. For example, if I'm doing defect prediction, the gender of the programmer, does it matter? No. Whether it's a female or a male programmer, does it matter? No. Your data set might contain that, so drop it. The nationality of the developer, no, drop it. Maybe you can't bring up an argument. An Indian developer is much better than a British developer. That is why the nationality matters. Then you have a problem, right? What if an Indian is sitting on the British side? What if he has taken UK passport and how does it help? So nationality, gender, there are so many. I am giving trivial examples, but you can identify things that doesn't matter. So you can you be strict and eliminate those things and represent the model using only handful of features. Then you'll be able to deal with your huge size. Size is not a problem. Next question. Ma'am, should I pick it up from the live comments or are you going to put it up here? How do we do that? Question 11. If we categorize with severity, do we write code for assemblers to predict defect? Uh, See, the severity classification is one of the desired features in software defect prediction. I want to use AI to identify how bad is the defect. That is a severity classification. Do we write code for assemblers to predict defects? No. Yes, you can. Maybe for Python interpreter itself, you can write a defect predictor. That's a good thought. You can do that. For example, see the assemblers and interpreters, they work at the language feature level, but the defects come from the application side of things. Okay, I'm not talking about syntactical defects here. So it's an yeah. This is a nice question. We need to think about this. If it is possible, in my opinion, I would answer this question in positive. I would say yes, if possible, we have to write a defect prediction model for these interpreters like Python. And if it becomes a part of the language, nothing like it. It's awesome. Yes, next question. While the next question come up, let me pick up one of these things here, some of the earlier questions. Does AI play a role in Internet of Things? Internet of Things is more of interaction between sensors. So you can collect data from those sensors and then apply AI to identify what you want to. So if because those sensors are small devices having very limited memory and all, right? AI requires good processing power, and you probably asking these tiny sensors to do AI is a bit of a too much. So you can collect all the IoT data, consider that as a data set, and then do your AI magic on top of it. That's how I would say things should be. Okay, MATLAB, okay, coming down. How can AI help in predicting performance of an industry? Okay, so this is we are talking about how is the banking industry doing? How is the medical industry doing? How is software engineering doing? And how is professional sports like basketball is doing? Yeah. See, you have to look at your AI problem in terms of a model. How do you describe your banking industry? Is it the share price of top 10 banks? Or is it the total number of unpaid loans? Or is it the number of credit card transactions per day? So everything in AI boils down to a model. And what are the features that you use to build that model? So if you can describe an industry in terms of 5 or 6 features, then you can model that industry. Once you have data for those 5 things, you can train the model uh, and then um, then judge the industry based on AI performance. Okay, question 12 has appeared. Does AI play a role in Internet of Things? I've answered that. AI 13, is there a better technology which will do the jobs tasks better than AI technology? I just said that there are more than 18 different fields participate in AI, right from psychology to computer science to neural networks to biology to so many other things. So it is not a technology, it is a combination of so many. You can't say that it is one technology like Python. To me, Python is a technology, piece of technology. Mean stack is a piece of technology. Angular is a piece of technology. A database is a piece of technology. AI is a technique. You can implement a technique using any technology. So language is very important there. AI is a way of doing things. It's a collection of different processes which can be implemented using different technologies. So better than AI. Sometimes, yes, AI is an overkill. See, if you are roaming around holding a hammer, everything looks like a nail to you, right? You feel like banging on it, right? So if AI is the only tool you have, even to log in, you will use AI, right? So it's you have to use the right technology for the right thing. Yes, there are cases where AI is an absolute wrong technology or wrong thing to use. Yes, so there could be alternate technologies where you don't need AI. Okay, for it depends on what task you have on hand. Okay. Yeah, question 13 answered. Question. Okay, let me pick up one more. How can we know that what type of data is suitable for AI? See, the data should have, see, like I said, you need to build a model. That is the objective in AI. To build a model, you need features. So your data should have values for those features, isn't it? Let's say you are building a model to predict the performance of the class. How many people are going to pass in this? Okay, what all data you need? You need the average performance of the student, average performance of the faculty, and the average difficulty of the question paper. Right? These are the three. Let's say these are the three parameters on which you are building the model. Now, if you have a data set which does not give answers to all three, then you have the wrong data set. So one of the characteristics of data is it should have values for the desired features. And it should not have too many undesired features. For example, students' gender. How does that matter? It is not required, right? So it should have less of what is not required and more of what is required. And then there should be at least some 30,000 to 50,000 cases. For example, we were trying to detect cracks in a chimney. So we got 60,000 pictures of chimney. So if you're detecting pneumonia, you need, or if you're detecting COVID, you can't analyze 100 samples and say, hey, I've written a COVID detector, AI-based COVID detector. No, not enough, 100. So if it is 1 lakh, yeah, then we are talking something sensible, right? So the characteristics of data is it should be complete in terms of rows. It should have things that you need. It should not have things that you don't need. And it should have sufficient number of rows. So those are the characteristics of data. And of course, you should own that. And it should be real data, real in the sense that it should not be artificially created. Okay. It should be as real as possible to the real world. Otherwise, your AI will give results which do not apply to the real world. Okay, that was the last question in this list. Any other questions? Or we have overshot the time, I think. 4:45, so over to team SIT. I'm happy to answer more questions. You can send it to me over my email. I'm available on LinkedIn. Any other questions? Did I miss any question? Okay, I'm getting many thank you messages. So yes, okay. Which language in AI would you suggest for a beginner? Again, English is what I recommend to understand AI. And yeah, I've already said I'm a fan of Python, so maybe Python, MATLAB, this might help. Can AI be dangerous? Who coined the term artificial intelligence? Okay, AI can be dangerous, and there are many cases where AI has been proven to be dangerous. In the recent experiment of self-driven car, the car applied brakes as soon as it detected an artificial fixture as a human. So it misinterpreted things and it gave a
Hello.
wrong output. Yes, AI can be dangerous. So the term artificial intelligence was coined in 1950 in a conference. Uh, so it is not one person. It is a set of people who coined the word artificial intelligence. So yeah, so John McCarthy is, I think some people attribute it to John McCarthy. There are plenty of definitions, but first time it was used in around 1950, I think. Okay. Yeah. Any
We
other
have,
question?
I think all questions are answered. So we have come to the end of the session. Thank you, Mr. Mahesh, for the wonderful session that we had today. Your talk has created new awareness in us to explore AI in software engineering domain. So we seek your expert and look forward for your continued support on similar occasions in future. Thank you once again.
Thank you for having me on board, and yeah, I welcome people to do internships with us, get in touch, pick up some problem statements and experiment. So we're always open for people, especially from SIT, and those who come with SIT recommendations, they'll be given priority. Yes, my alumni, so I'm here to do whatever it takes. Thank you for having me.
Definitely will make use of this opportunity
Yeah.
and see that we take the internships. Thank you once again.
Thank you. Thank you a lot.
I thank all the participants for joining this session. I request each one of you all to provide your valuable feedback on this session by using the link sent to you. So let us join back tomorrow at 11 a.m. to listen to Mr. R. Subramaniam, advisor and former Vice President, Hughes Communication India Limited, for a talk on new trends in satellite communication. Thank you, Anand.
So I'm just typing my two email IDs here in the chat. So you can write to any of those two email IDs. Someone asked one last question. Can you do online internships? Yeah, we can, but it is slightly difficult. We can give it a try. Okay, some people are doing one or two problem statements with us. We can discuss. So get in touch. There are no generic answers for this. We will try to work together. Okay, so thank you very much once again. Have a nice day, nice evening, and good luck to the rest of the webinars and this great initiative. Appreciate it.
Thank you, Mr. Mahesh.
Thank you.
Our remove
Camera.